Welcome to the trading floor. Okay, think about an actual stock exchange trading floor for a second. It is chaotic, it's high stakes, and success comes down to one thing: split-second decisions. You have to invest your time and resources exactly where the returns are highest. Well, your Cambridge Computer Science exam is literally no different. Today in this explainer, we are tearing down the strategies you need to maximize your mark potential. We're looking at syllabus codes across the board, whether you're tackling 0417, 0478, 0983, 0984, 2210, or specifically today's deep dive into the AS and A-Level 9618 syllabus. We are tackling a massive battleground: file processing on serial, sequential, and random files. To show you what I mean, let's look at a real past paper question. Imagine we have two students. We'll call them Alex and Sam. Alex is the kind of student who overloads their answers with raw computer science facts. They know every definition, but there is zero analysis. Sam, on the other hand, is always rushing. Sam completely misses the command word requirements and just writes whatever comes to mind first. When you look at their answers side by side covered in red pen marks, it's obvious they're both losing points, but for completely different reasons. We aren't just looking at textbook definitions today. We are analyzing the source material directly from the examiner's playbook to decode exactly how you can avoid being an Alex or a Sam, invest your time where the marks actually are, and make those split-second decisions to secure top grades. Listen to this hard truth from the source material. Senior examiners consistently point out this exact quote: "The difference between a B and an A star in computer science often comes down to how well you understand file processing on serial, sequential, and random files." That's a huge statement. Students regularly hit a brick wall with evaluating algorithm efficiency here. It's an incredibly high-stakes topic. It's not just about, regurgitating what a sequential file is. It's about demonstrating a conceptual, rock-solid understanding that you can transfer to completely unfamiliar contexts under immense exam pressure. You've got to prove you know why a system is built a certain way, not just how. So to demystify that grading process and get you thinking like a top-tier candidate, here is our tactical roadmap for today. Number 1, theoretical connections. Number 2, technical methodology. Number 3, examiner warnings. This is where we'll look at the exact traps people fall into. And number 4, the exam playbook, bringing it all together into an actionable system. Let's get right into it.
Let's start with part 1, theoretical connections, building the foundation. Now, before we can even talk about files, we need to talk about how you structure your answers. Remember Alex and Sam? They fail because they don't understand computer science-specific assessment objectives. You need to decode the command words like evaluate, describe, or analyze, and use what we call the PEAL framework. That stands for point, evidence, explanation, link. Top students structure every single answer this way. Because here is the secret revealed by the Cambridge Assessment Framework. Principal examiner reports explicitly show that candidates who achieve significantly higher marks do something very specific. They reference cross-topic connections. They don't treat file processing as an isolated island. Instead, they show how the theoretical architecture of serial, sequential, and random files integrates with other syllabus areas, like data structures or hardware limitations. To get top marks, you need to show the examiner you see the whole picture, not just a single pixel. Now, before we continue and look at how to actually build these connections, subscribe to our YouTube channel Ace the Exams at acetheexams_IGSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Seriously, getting those fundamental strategies locked in is how you beat the curve. So what actually builds that cross-topic picture? Well, the core principles require precise definitions and a deep understanding of causal relationships. The assessment framework heavily prioritizes analytical depth over superficial breadth. This is where Alex messes up. Alex just lists everything they know about a serial file, but you can't just memorize facts. You need systematic analysis and evidence-based reasoning. Let's apply the PEL framework here. When you make a point about choosing a random file over a serial file, what is your evidence? What is the explanation of the exact causal relationship between that choice and the efficiency of the algorithm? And finally, how do you link it back to the specific exam scenario? That is the analytical depth the examiner is actively hunting for on the page. Okay, moving on to part 2, technical methodology and what we call the method mark strategy. This is where we take the theory and turn it into actual points on your exam paper. It's about knowing the procedural frameworks where method marks are reliably, predictably earned. The practical programming lifecycle for file processing applications follows a strict, non-negotiable sequence. Design algorithms, implement solutions, test thoroughly, and evaluate performance. This exact sequence is your gold mine for method marks. Now, I want you to imagine a 60-second timer on your screen right now. If you were forced to rewrite one of Sam's rushed answers in under a minute, where would you start? You'd start with the method.
In complex past paper problems, marks are awarded for the process, not just the final outcome. Let's say you're writing pseudocode to append a record to a sequential file. Even if your final code has a minor syntax error, a structured methodology showing you opened the file, checked for the end of file, wrote the data, and closed it proves that you understand the systematic processing required. You literally grab marks just for showing your logical working. Red pen marks transform into green check marks when the examiner can see your systematic thought process.
And this brings us to a massive divide between an average answer and an A-star answer. It's the shift from superficial extraction to critical data interpretation. Top-tier candidates don't just do a basic surface-level read of a binary representation or a file structure. They perform calculations and draw evidence-based conclusions from it. If you are given a complex file structure in an exam, the examiner wants to see you interpret that data critically, applying relevant principles to draw a meaningful conclusion. This is the computer science success blueprint in action. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at aceexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to Ace the Exams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, Act 4. Welcome to the interactive workshop segment. We're diving into Part 3, Examiner Warnings. These are the specific, critical mistakes that rip marks away from students every single year. We are going to make this interactive, so get ready to think fast. We scoured the principal examiner reports, looking for the specific data about where students consistently drop marks, and it all boils down to exactly 3 major pitfalls. For our first interactive challenge, I want you to imagine a complex computer science data table on your screen. I'm putting 60 seconds on the clock. Challenge 1 is a data scan. If you were scanning a table of file access times, could you extract the core trend under pressure? Most students panic, but if you know these 3 mistakes, you'll know exactly what the examiners are trying to trick you with. Let's break them down. Here they are. First, examiners report that students frequently confuse cause and effect in file processing. They mix up why a sequential file takes longer to search versus why a random file requires a hashing algorithm. Second, forgetting to check boundary conditions in edge cases. Okay, challenge 2, find the flaw. I'm going to give you a flawed sample paragraph. To add a user, open the file, write the data, and close it. What's the flaw? You have 2 seconds. The flaw is completely ignoring boundary conditions. When you write to a file, what happens if it's already full? What if it's completely empty to begin with? These edge cases are an absolute goldmine for marks, and Sam always forgets them because they rush. Third, and perhaps most fatally, giving generic non-contextual answers. That third point is the ultimate examiner alert. The classic mistake is providing a generic answer that you've memorized from a textbook, completely ignoring the context given in the question. Always, always link every single point directly to the given scenario. Okay, challenge 3, speed writing. You have 30 seconds on the imaginary clock to write 1 perfect Peel paragraph. Ready? Go. If the question is about a hospital's patient record system, your point shouldn't just say, random access is faster. Your explanation and link should say, random file processing allows for immediate access to an individual patient's record during a medical emergency, reducing potentially critical search delays. Boom. Context is everything. You just secured the maximum marks for that question by linking the theory to the real-world scenario. Let's move to our final section, Act 5. This is where we bring everything together into a cheat sheet recap. We are building the evaluative strategy, the exam playbook. If you want that progress bar of your mark potential to hit 100%, this is how you do it. To hit the higher order assessment objectives demanded by the Cambridge syllabus, top-scoring candidates consistently demonstrate evaluative thinking. It comes down to a complete answering system based on 3 rules: command word decoding, Peel framework application, and a time management matrix. When you're evaluating, you must consider multiple solutions. Ask yourself, could we use serial or sequential here? Then analyze the trade-offs. Sequential is easier to implement, but random gives much faster retrieval. You have to acknowledge the limitations. A random file might waste physical storage space due to the hashing algorithm generating empty blocks. And finally, justifications, supporting every single decision with solid evidence. This matrix right here is exactly how you prove absolute mastery over the subject. So the split second you encounter a file processing question, here is your definitive 5-step timeline. Step 1, deconstruct the question, decode that command word. What is it really asking? Step 2, extract the relevant data from the scenario. Step 3, select the correct analytical framework. Step 4, execute your analysis using Peel.
And step 5, present it clearly. Following the standardized sequence ensures you never miss a required command word or a crucial piece of context. It stops you from being an Alex who brain dumps, and it stops you from being a Sam who rushes and misses the point.
And remember this golden rule: secure the method marks. You absolutely must use clear notation and correct terminology. If you were describing a random file, use exact terms like hashing algorithm, record key, and direct access. Execute your analyses with crystal clear working, verifying your results at every single step. Marks are awarded for your logical reasoning process, so make that process highly visible to the examiner on the page. Listen, students who implement these computer science strategies see an average improvement of 2 full grade boundaries. But that only happens if they practice consistently with our weekly videos.
We've covered the theoretical connections, the critical technical methodology, the top mistakes to avoid, and the ultimate evaluative playbook. So I'll leave you with this final provocative question. How will you apply the method mark strategy in your next past paper? Next time you sit down to revise, actively visualize the systematic playbook. Don't just casually read the answers, structure your thinking. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at aceexams_IGCE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams_IGCSE and click that bell. Don't let another exam pass you by. Also, drop a comment below with your exact target grade for computer science and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep pushing for that analytical depth, and I'll see you in the next one.